PDF or PowerPoint? Just click or roll. That's why I'm asking.
You can use also the PowerPoint. You can use keyboard.
Okay, it's PowerPoint. So we just click
With the
and
mouse,
change.
we can click.
Okay.
Right? Not scroll. Yeah, you can try. I will be presenting. Do you have another one? Yes. I'll be presenting you.
Okay.
Yeah, you should start rolling.
Yes.
Are we good? Okay, good evening, everybody, and welcome to the final presentation of the third case study of EBEC Final Brno 2017. Our case study today is offered by our partner, Honeywell, and it is about home thermal comfort technologies. After one intense day of working, we have 14 teams coming from 14 different countries, European countries, and they will be presenting their results, the results of their work throughout the day. But before we introduce the first team, which is the team coming from Greece, let me have the honor to announce our jury that will be evaluating the job that you have done throughout the day. So we have from representative from Honeywell, Petr Pohacek, and Miroslav Molinek, and Libor Sheda. We have also from the University of Brno Technical University, Andrei Pech, and from YITS, we have Miroslav Zozelka. Thank you for coming, and thank you for evaluating the job. So now I will give the microphone to the first team. Bear in mind that you have 8 minutes of presentation. Afterwards, you will have 3 minutes of questions from the jury. Good luck.
Thank you. Hello, everybody. We're a case study team from Greece, and I'm Alexis. Our main objective for today was to design a product that combines healing and cooling, domestic healing and cooling, and data utilization. Here you can see the factors of thermal comfort. Most of the domestic heating and cooling systems nowadays, they can control only one of them. So we thought a product that uses fuzzy logic and can control more than one of them at once.
Hello, my name is Dimitris, and I'm going to talk about fuzzy logic and genetic algorithms. So, as you can see, fuzzy logic has many, it uses linguistic variables instead of mathematical ones. So it has the ability to, sorry for that. It can be implemented better for control. And the nature of fuzzy logic also tackles the uncertainty and non-linearity better. So as for genetic algorithms, they have many advantages, as you can see in this slide. For example, they work good for environments, noisy environments, with lots of inputs. And for example, such an environment would be a house, and those inputs would be temperature and humidity and many more. For this reason, we use fuzzy control theory for our product with genetic algorithms for the software. So our product is ThermoSmart, which is actually a clever thermostat, and it actually adjusts the temperature and humidity levels around the house, and it uses fuzzy neural control algorithms to predict the ideal conditions for whoever comes in the house. Of course, ThermoSmart doesn't come alone. It has indoor and outdoor sensors for humidity, temperature, and motion sensors. Of course, we have some extensions that you can build your thermostat, ThermoSmart, sorry. For example, you can add fans, dehydrators, or air conditions. Sorry. We also thought of a smartphone case which collects the data from the user's hand, the temperature. And as we saw earlier, temperature is a crucial comfort parameter. Excuse me. Metabolic rate is a crucial comfort parameter. And with this case, you can have your phone, and it adds an additional input to the genetic algorithms and the fuzzy control for the ThermoSmart system. Thank you.
Hello, I'm Tassos, and I'll talk to you about marketing and business opportunities. That's why I've prepared a SWOT analysis in order to give you the full picture of your investment. Okay, let's see. Our products, as units, are not innovative, and you've probably seen them before. In addition to that, there is already a market for cooling and heating systems, for thermostats, etc. But it's a combination of all the above that makes us special. And of course, there always room in the market for a new investor, especially as powerful as you. Honeywell's brand name as a successful technological company, and the trust that has been built over the years with all the partners, can play a significant role in our campaign strategy. Unfortunately, when you enter the market, your competitors will try to push you away, and you'll probably have to make a slight price reduction or offer a special offer or a special package in order to gain some ground and make a name out of your product. Okay, our product is an integral part of the smart home and can connect with the main operating device of the smart home. Machine learning is the future of artificial intelligence, as it can adjust its settings by studying the user's behavior. It provides healthy conditions to live, as it can adjust temperature and humidity to normal levels all around the house. ThermoSmart is easy to use and easier to live with. It even saves money for the user by using smart power management, a concept which can expand by using renewable energy sources and turn smart home into green smart home. Last but not least, ThermoSmart is compatible with futuristic innovations and can open doors to partnerships with other companies.
So hello, my name is Aris, and I'm going to talk to you about what we thought of ThermoSmart, what we imagined that ThermoSmart could be compatible not only with today's technology, but also with some futuristic innovations. We found the most interesting of them, and I'm going to present them to you. So personal cloud is basically is a motion tracking device which tracks users, people in the space, and provides them with their own direct localized cooling air. So this is said, it is said that such a system could reduce energy consumption by 90%. We also got Ice Bear, which is basically warm air which gets out of the building to a cooling device which uses an ice, and then the cooled air re-enters the building, re-emits in the building. We got heat pump technology, which is basically a central air conditioning system which uses off-peaks seasonal electricity to warm an entire home. So what we are thinking of ThermoSmart is that it could co-work with technologies such as Ice Bear or multi-layer installation, but it could be also the stepping stone product for personal cloud or heat pump technology. So this is all from us. Thank you for your attention, and build your own ThermoSmart today.
Okay, I will start. Thank you for your presentation. Can you maybe elaborate a bit more about the iceberg technology, that you mentioned in the futuristic innovation section?
Okay, we found out that it takes a warm air from the building, then gets it through a cooling device which uses ice, and then emits it back into the building. I think we have a more detailed presentation in the PDF file. Okay, so thank you.
We can hear with you.
Yeah, you can hear me good.
Yeah.
Okay, so my question is more about you mentioned the linguistic variables and non-linearity in your part. What is it? How you want to use that?
Yes, it's actually the nature of fuzzy logic, which uses linguistic variables, and it's easier to get implemented, to be implemented for control. For example, if you don't have to program a program with how can I say that? With mathematical variables like coding or something like this, it is a new kind, let's say, of logic, of computer logic, that uses linguistic variables like very much, not 100, for example, like very much, very little, medium, like, yeah, keywords. It's actually a very big topic to analyze right now, but it's how fuzzy logic works.
And the non-linearity, you have that.
Yeah.
How you want to use it? Why it's not a linear system?
Of course, a house, for this example, a house is a non-linear system. There are people coming and going all the time. So I guess it's more like you don't have a program that goes like if temperature rises to 35 degrees, do that. It's more like if temperature is high, do that. So it's more like I don't know about non-linearity, as you say, but for the example I'm trying to use, it's about how easy it is to control it, to control the system with the algorithms.
Okay, good. Thanks.
Thank you very much, Team Greece, for your presentation and answers to questions. And now we will present the second team. So thank you. Okay. And now it's time for the second presentation from team Benelux. So good luck.
Comfort, moisturize our future. The product that we designed is designed to increase the comfort of the inhabitants of a home. Comfort, it's more than more than just temperature, as we all know. Another important parameter is the humidity. In most homes, humidity isn't controlled at all. And even if you have air conditioning, the air conditioning only controls the humidity as a byproduct of controlling the temperature. On top of that, the air conditioning is often over-dimensioned. Imagine a rainy day in fall, your outside temperature is comparable to the temperature that we want inside, but due to the rain, the humidity inside of the house keeps rising. But the air conditioning cannot solve this problem. It's at this point that our ComFort comes into play. The ComFort will make sure that we'll stay in the humidity regions that we want, so between 40 and 60%. And it will do this by using metal organic frameworks.
So let's shortly introduce metal organic frameworks, a very promising and advanced material. So metal organic frameworks are ultra-porous nanomaterials with immense surface areas, and they are built of inorganic and organic part, as you can see in the picture. What truly distinguishes MOFs is the variability of both the inorganic and the organic part, leading to tunable properties, just like the affinity for certain chemicals. And this is exactly what we want for our application, sensing humidity and regulating humidity. Let's start with with sensing humidity. So MOF thin films can be coated on top of a refractometer, allowing the absorption of water. And in this case, we can determine the humidity in function of the refraction angle. Of course, this humidity sensor is not the most important because humidity sensors can already be found on the market. But now let's have a look on the second aspect, the humidity regulator part. So MOFs can be used as energy efficient humidity regulators by applying the standard adsorption-desorption principle, which allows us to exploit the temperature dependent adsorption and desorption behavior. So a MOF can be designed that absorbs water at room temperature and desorbs water at higher temperatures, and this can be exploited by us because we can integrate this in the following system. You can click. So in this system, we bring two exactly the same MOF columns into the ventilation system of a room. So first of all, there is the MOF column that absorbs all the time, that absorbs water all the time at room temperature, and then there is the column that constantly desorbs and regenerates at an elevated temperature. These columns constantly switch function, so we can use it in a continuous process. Also, the exothermic absorption and the endothermic desorption are coupled, which allows us to use them in an energy efficient way. Okay, a last awesome result of the tunability of MOFs is that the same principle can also be applied for other gases like CO and CO2. They can also be regulated and sensed, and this is a gigantic thing because these are also relevant gases in a home situation.
So we will now discuss the IoT and data processing applications we came up with. So firstly, we will give an overview of how we will regulate the humidity in our home. So let's start to the left with the MOF unit here. So the endothermic desorption of the one MOF unit gains its energy from the exothermic absorption from the different one, and also gains energy from the residual heat of a water boiler. So then dry air comes out of the MOF unit and goes to the rooms in our house. So suppose we have n rooms. Each room has a radiator, a fan with a certain flow rate, which is determined by the humidity in our home. So the drier our room is, the less a fan will blow. And these things are humidity sensors, so you have a humidity sensor in each room. And the humidity sensor can be a MOF sensor as well, but it doesn't have to. Then the dry air leaves our room and goes back to the MOF unit. Yeah, you can click. The second application we came up with was learning the schedules for the different inhabitants of our home. So what we want to know is which inhabitant will be where at what time and how long they will stay there. If we know this, so we either know someone is in a room, or we will predict using machine learning that someone will be in a room. If we know this, we have to keep our room, the temperature and the humidity, we have to keep it within the comfort zone we defined earlier. But if we know no one will be there, we can broaden our comfort zone, because when we predict that someone will come or someone is there, we can go back to the first comfort zone anyway. So this way we save energy. Yeah. So if you want to learn these schedules, we have to be able to identify inhabitants in our house. We can do this via two ways. Either we make no distinction between the schedules of different inhabitants, so we make one schedule for each for all inhabitants, or we make a personalized schedule for each inhabitant. We think that the second option will be more precise, but more expensive. So if we make no distinction, we can just put motion or thermal sensors within each room to detect any person. But if we do, we came up with, for example, a smartwatch application that each inhabitant wears with a location sensor, so we know where everyone is, and we can predict using this data where everyone will be. Or we can use image recognition, but putting cameras in your house might be a bit expensive and or creepy. Okay.
To end this presentation, I will do the business side. So first we try to calculate how much MOFs you need to put in the house, assuming an ideal temperature of 22 degrees, and that we start from air in the house that's fully saturated, which is a worst case scenario. We calculated that we need to remove 4 kilograms of water, which means we need 12 kilograms of MOFs, and if you convert it to euros, it's 180 euros for 10 years, which is a pretty cheap deal. So it's nice, and it doesn't take too much volume, so it's easy to put into the system. Next one. Finally, the business timeline we want to follow. First, we want to start on a small scale in lab as a kind of proof of concept. After that, we will go to commercial buildings, because they already have the infrastructure we need, like boilers and the air pipelines. After that, we want to ask the government to subsidize the households that want to build or to buy our product, because it's so energy efficient, so there should be some subsidies. And then in the end, we will give it to the households, and we hope it will spread over the world. Last slide. So I hope you enjoyed the presentation and you had a comfortable time.
How do you plan to regulate the MOF dryness in your home, or will it just dry your home completely?
That's what this schedule was about. So yeah, you have a humidity sensor in each room. So on a per room basis, you can regulate how dry a room should be, and it gives feedback to the fan here. So if your room is not dry enough, the fan will start to blow dry air from the MOF unit, and it will dry down the room.
Yeah, okay, thank you.
Is that what you meant?
I have another one. You have the
Yeah, no, we put it in the system as was shown in the previous slide, in the box that was shown here in the diagram.
In the ventilation system.
Yeah, and this is actually, if you just convert it, 35 liters is only this amount, so it's not too much. It's just a box of 30 centimeters by 30 centimeters, so it won't take too much place in it. Most you. Yeah, as I said, you have to replace it because MOFs are very stable materials. You have to replace it maybe once every 10 years, but probably even less, because everywhere I took worst case scenario, And MOFs are well known for its almost eternal stability, so that's why we choose those
It's not that once it
materials.
has the moisture in it, that it stays in. That's the regeneration part.
Yeah.
For example, sometimes you have to give moist to the room, and then it can regenerate and put the moist to the air. But if most of the time you have to take moist out, it can also just regenerate and let moist drip out.
That's Yeah, so you have two columns inside the ventilation system. One column is always absorbing water at room temperature, because at room temperature it has a high affinity for water, and the other one is getting heated with the heat that comes free at the absorption side. And when it's getting heated, it's desorbing in the other column. So it's actually just a two-column system inside the ventilation system.
Hello.
So as I said, it's really cheap. It's like the MOFs itself. They already have almost all the infrastructure that's needed, like the boilers for the heat exchange. They have the air pipelines in which we want to flow the air. And most important thing is that's really energy efficient. So they are also saving on their energy bill. So that are probably the main points we are focusing on. Next to, of course, the fact that the green image of the company will also be good for its corporate social responsibility. And of course, for most commercial buildings, like for instance this building or the exhibition center in Brno itself, it's like good humidity and temperature and hence comfort is like a main point they should focus on.
Personnel of the company will also perform better, because if you have good rooms with good conditions, it's always nicer to work. Because our rooms here, they're hot and they're moist. So.
Thank you. Yes, well done.
We only see the short resume of our mathematics on one slide, so would you like us to send some details on the mathematics? Or?
I think the time is done.
No, just
yeah.
Not now.
Thank you. And now for the third presentation, we have Team Central from Prague. From Brno, sorry.
So this is not just for the streaming now? Okay. So can we start? Okay. So dear jury, ladies and gentlemen, let me present you our case study. First of all, I would like to start with basic introduction to thermal comfort, as we also have seen in our assignment task. So thermal comfort is one of the most essential aspects in HVAC design. There are also some other aspects such as effectivity of the system, energy consumptions, and of course also initial costs. The main factors of thermal comfort for people inside the buildings are air temperature, relative humidity, radiant temperature of the surface around, and also the airflow. First of all, we have set up some customer needs. As you can see, needs, wants, and expectations are not the same all the time. So first of all, let's start with economic point of view, with energy savings and low initial costs, which are like most important for every customer. Then I would like to proceed with how easy is our concept and system to be installed and used. We mainly aim for basically for new design, new buildings, but our system is also feasible for all the projects. But it's need to have a lot of construction adjustments, and it's not so cost effective. Of course, it's also connected with the prestige, because as we all know, all the people and companies like to present that they are environmentally friendly, and they would like to sell or rent apartments and buildings that they do not hurt the nature and do not help to produce the greenhouse effect. Of course, last but not least, technical support 24/7, it's really important, and references of already built projects with hard data that the system is cost effective and works fine is really important. Market segmentation, so basically we aimed for the companies and owners of the apartment blocks, which a lot of apartments and people living there. Then like for the public sectors, for the buildings such as hospitalities, universities, and schools. And speaking about the commercial sector, buildings like administrative offices or business centers. So let me introduce you the brand of our service, which stands for COBAM, which stands for Commercial Building Energy Management.
Okay, thank you. Our service using modular systems. Those modules could work together, and also they can work all around. And we are measuring data and evaluate them, and also those data could be used for machine learning improvements. We are using modern and environmental friendly technologies, and we are using a cost-effective way, or our solution is a cost-effective way to how to reduce heat and electricity expense. In this slide, you can see some of our devices we are using. We are using, for example, a cogeneration unit which producing heat and electricity together. Also, this device could be combined with three generation technology, which producing cold together. And the other device is heat exchanger, recuperative heat exchanger, which we are using for thermal comfort inside the buildings. Also, we are using a heat pump. This heat pump is used for to heat up the water. Our solution is based on those five models. First model is a one-time solution, so we are using this as a first step of marketing level. We are offering people consulting, and also we are offering optimized by a smart circular pump. And the other level is recuperation. The recuperation unit, which is connected with all of the devices, is smart, and then we are using cogeneration unit with the possibility of regeneration, and also we are using heat pumps, and all our systems is connected with sensors, and they are controlled, but we are offering sensors and controlling alone.
We made a small analysis with an example of office building of approximately area of 4,000 meters squared. Here all of the 5 systems are taken in account into this analysis, and here you can see the possible savings. One-time solutions, so balancing of a heating system is the first one. Recuperation can lead into reducing of heat loss. We have taken account that cogeneration would produce 2/3 of heat required, and heat pumps would produce another 1/3. and sensors and controlling this value can't be exactly evaluated, so we have just made some estimations. According to this calculation, we have made some additional info for it. So maybe I hope that you have additional document also already on your table, and you can look at it. About the sensors, we have to measure thermal comfort inside. So the most some sensors are quite expensive, so we only have decided that we would measure temperature and humidity. Also, we want to measure temperature outside, so we can find out what the savings for recuperation is. Energy consumption, so gas for the cogeneration unit and electricity for both recuperation and heat pumps. And other sensors, for example, pressure gauge at the heating system, so we can balance it, and temperature sensors at the outlets at the recuperators, so we can exactly find out what the savings are. And we think that this would lead to low amount of data process. About the machine learning, we have find out that there's quite a high rate of failure. So with this high amount of energy, with possible fail, it could lead to a big amount of money loss. So we only want to collect the data, so in the future the better algorithms could be developed.
On this graph you can see cumulative cash flow with first investment around 400,000 euros with annual savings more than 60,000 euros, and its payback is around 7 years. Something about marketing, we've got two ways how to sell our product. It's direct, going straight to the customer, or indirect, like making presentation and workshops to let them know that we can do some energy supplies. And we are focusing on civil engineering companies and big cities or municipalities. That's all. Thank you for attention. I'm really looking forward for your questions.
Thank you for your presentation. We have 2 minutes for questions.
Okay, the recuperation system is referring to standard. I don't know how to say it because I'm not sure.
About the heat pumps and cogeneration, we have the saving is caused by a lower price, as we have compared it with heat from central district heating, and when we use cogeneration, so we combust gas and made heat this kind of way, or heat pumps where you use electricity for pumping heat pump to a lower quality level. The price for 1 unit of heat is significantly lower. Excuse me, can you repeat the question? This one. Yeah, so the first one? Yeah, we are sorry for the missing reference here. It was from a Chinese article which was published in Springer, but unfortunately it should be somewhere here. But we haven't found it. But in case of interest, I can provide you the information after the presentation when we find it in our additional document. No, unfortunately, we didn't put it there, so we can put it here and simply just. Thanks.
Test. Italy? Team Italy. Ciao ragazzi, venite pure. And now for the fourth presentation, we have Team Italy. Let me remind you that you have 8 minutes of presentation plus 3 minutes for questions from the jury. So your presentation may start.
So good morning, everybody. We are DDLP. So 2018, Diego comes back home after a very bad day. Honey, his personal assistant, suggests him to make a warm bath, and she tunes the home temperature according to Diego's emotions. And so Diego now is happy, and so thank you, honey. But now, to be more clear, we will talk you about our research phase, what we want to do, why, how, and in the end, we will talk about business. And so let's start with the research, where we discovered several problems, such as difficult tuning of heating system, different perception from person to person of the heat, a lot of energy waste. Then there is a passive parameters control. There are no feedback from the users, and so the customization is necessary.
Now let's move on what we want to create. It is basically a smart heating system that has the following features. So it is modular and customized. It is safe and user-friendly. And then we want the system to understand what the user habits are so that we can suggest the settings to the user. Let me be more clear with this picture. It is basically a schema that is taken from the closed control loop schema. It's a little bit different because here we have a thermostat controller whose output goes to a transducer and then to the cooler and heaters. These sensors, it's very important for the modularity that they have a common interface. So thanks to this, we can warm up the room and thanks to a feedback system, sensor could measure the temperature and making the difference between the desired value and the effective value, we can understand which are the changes that need to be done. But what is the desired value? Where does this come from? We have 3 different operating modes. The first one is automatic settings. So it's the system itself that understands the temperature that the user needs. Or we can give manual setting of the users. Or moreover, just suggestion to the user that he can accept or not. The system installation needs 2 phases. The first one is just a learning, just to learn user habits, and it lasts basically 1 month. After that, the system understands, thanks to the collecting all the data, it can automatically set the parameters of the system. But why? Why people should buy this system? Because it is more comfortable, faster, and easier to use. And it reduces energy wastage as well, and the modularization reaches a wide range of users. What does it mean? User basically will be domestics, households. So this is the target costumes.
let's now talk about how this system will be implemented. It features a main controller for the house that is composed by those three components, and it is attached directly to the heating system. The first part of the controller are just interfaces that can be implemented like from with the wall panels or application of smartphones, and they just collect the user inputs like speech or other numeric values, and elaborates it through a speech and voice analysis to feed it to a machine learning block. This machine learning block just takes the elaborated speech and the other inputs from the user, together with sensory data that comes back from the components of the heating system, and outputs controls for these components. It has to be noticed that the user can overdrive, can always make manual inputs to this system, so that he has a higher degree of freedom. So the speech and voice recognition component, the second component, will be implemented using natural language processing to understand what the user wants. And through voice recognition, he will be recognized by the system, so the system can output controls specifically tuned for him. So the real implementation of this system comes from deep learning algorithms. For example, we can use one-dimensional convolutional neural network that extracts audio features from the raw audio data that the user inputs through the wall panels or smartphones. These features are easy to be computed, so it can be implemented in a wide range of devices that came like embedded systems and IoT appliances. So the resulting features extracted from raw audio data are analyzed by the LSTM, that stands for long short time memory. That is the core algorithm that understands what the user wants, so it does speech and voice recognition. And this system can also be extended to do say sentiment analysis, emotional analysis, so he can understand not only what the user wants and who he is, but also how he feels. So, for example, he can cool the environment if anger is detected, or exploit other emotional components of the human will. So, as a further improvement, he can analyze energy consumption from the data of the sensors, so he can output controls to make the components be more energy efficient. And lastly, he also can do a large-scale data analysis to understand energy usage throughout the whole country, the whole the whole user audience.
So we talk about business, and we have used this example to explain the business part of our project with 4 rooms, and for each 2 rooms we have the wall panel, sensor, and the temperature devices. And so in this table we can see the manufacturing cost and the total cost on the bottom. And in these second tables we can see the equipment cost, installation cost, the profit margin, and the final product price. The sales challenge will be the site, e-commerce, mobile app, and social networks. And the last but not least, there is the scalability. And so the next challenges will be to spread our projects in office or public buildings like schools and museums. So thanks for the attention, and we are ready to warm up the word.
Okay, do you hear me? I guess yes. Okay, so first question from my side. You introduced the product, you introduced a price for it, and my question is, Have you quantified and have you thought about the value to the customer? For example, if there is any possibility for the product to save money in future, or it's just a nice add-on? So maybe can you elaborate more on this topic?
Can you repeat the question? Because just the last part of it. Can you repeat the question, please?
If I put it simply, have you thought about return on investment of such product?
Yeah, the return of investment comes by using data or just by selling those things, because it is we did it has a profit margin into it, so it can be used to just sold and thus gaining profits.
How would your system work without the user voice input? For example, if the user just doesn't want to speak to your system.
Without speaking, it can be used like just a normal thermostat by inputting numerical values for temperature, humidity, or other parameters, and the system will just do what the user inputs. Or it can be used to just speaking into the interface, and the system will understand it. The user can choose with both the type of inputs if he wants to do just what he said, or to receive a suggestion for the system, or just letting the system do what he thinks it is better for the user. So for what it has learned.
So probably the last one. In these future steps, you have something called data mining, right? What do you mean by that? Some example.
By data mining?
Yeah. How do you want to use that in that system?
Well, data mining is extracting data. So it is extracting hidden patterns from the data. So the data will be like settings from the user in the first time that the user uses it. So, for example, the data collected will be like that around this hour the user is in home and uses like some setting of temperature and humidity. In another period of the year, he uses sometimes some different settings. So these are just data, and the system tries to understand what is the pattern behind these settings, so he can forecast it and do just what the user will do. So for the user, it's just comfort.
It is okay.
And now for the fifth presentation. Okay. And now, after solving this technical situation, we have Team Balkan, which is the fifth team. So may your presentation start. Let me remind you, you have 8 minutes of presentation, and afterwards 3 minutes for questions.
We use mic, right? Yes. Use mic. Yes. So we need to stand here. Mic capture things. Okay. Hello everyone. We are team E136 from Serbia. Please visit our website for more information about us. So we are a company that's making your home more efficient, and we have business plans separated into multiple sections, which we'll cover during this presentation. The first section is our customers, and we researched that customers want from these devices need to be low on price and efficient, also less noisy and in smaller size. So for our customers, we choose owners of small and medium-sized homes from Europe and also from middle and upper middle class. And our goal here is to make homes efficient and families even happier.
So this is how our device looks like. As you can see, it's such a tiny device with a lot of functionality like artificial intelligence, cloud control, and calendar synchronization. And I will demonstrate now how this device is working. All you need to say is just eHome. What's the current temperature?
The temperature is 25 degrees.
Okay, or you can say eHome, my mother-in-law is coming.
Lowering the air temperature in guest room by 5 degrees. Winter is coming.
Okay, it's a smart one.
Okay, for the technological part of the project, we show that the eHome system controls heating, cooling, reads the sensors, has smart prediction of data, it's modular, it has voice control, it's eco-friendly, syncs with your calendar, and also communicates with the cloud. As for the communication with the cloud, as you can see, the data is sent to the cloud where the artificial intelligence analyzes the data and sends the best result back to the system. As for the sensor that we use, we have temperature, humidity, motion, and sunlight sensors. Those are the only sensors that we use in our product. The main thing of our product is the artificial intelligence, and we base our product on Google's DeepMind system because it's proven to be very efficient, and Google decreased 40% of its billing for cooling system by using DeepMind technology for that. And the system reads sensors data, controls all aspects of our home system, and receives feedback from the user. So if user wants to for example, increase or decrease the temperature, he can say to the device what he wants, and the device will learn that and improve it. So it's improved its data set also by training constantly on live data from other households, and it reduces the cost of living ultimately. So this is the main diagram of how the system works. So we have our cloud on the left, and on the right you see the eHome system, and these are the sensors which send data to the sensor inputs on the artificial intelligence. And also we have control line that's user feedback from the calendar and the voice recognition of the system. And we get the response from the system, which eHome then uses to control heating and cooling in our home. And for the security of IoT, it's a very important thing because the device is connected to internet constantly, and it's very important, and we will do a lot of things to improve the security of it, and we want to avoid this kind of things. So
I'm sorry, Dave. I'm afraid I can't do that.
So if you know the movie, you're going to know the thing.
So about the marketing, first of all, we are going to use the crowdfunding websites like Indiegogo, Kickstarter, and GoFundMe, and those are the great way to get initial money. But not only for development, you get initial sales, but they're also the most important use of these websites is to get a lot of media attention and to get early adopters of the new products, because people are constantly looking for new products to buy on those websites. We of course are going to use standard social media websites, and we are going to create hackathons after our product launches. And hackathons are going to have two purposes. First purpose is of course for developers to create new extensions and modifications of our products, which later we can use in a second version of our product. And second is actually for hackers to hack our products, so we can make them more secure. So why are we different? We use artificial intelligence, we have voice control, we are very model and expandable, we communicate with the cloud, and we control shades of the windows. And that is the example of communication. Each of our devices communicates with the cloud. For example, if a cloud appears over the house, that house via sensors can send that information to the cloud, and that particular house can lower cooling because there is no sun anymore, or increase heating. But it also notifies the cloud, and that cloud notifies other surrounding houses, so they can prepare themselves on time for that. Biggest problem in European Union by energy consumption is that 70% is spent on heating, then 27% on lighting and electrical motors, and only 3% of heating. Per household, it means that people pay 40% for heating, and we want to adjust that and lower that. About our financial part, this is how much our system costs. It's based on 6 rooms, so we have a main unit, we have 6 sensor packs, we have remotely controlled thermostatic radiator valve, we have shade controls and other costs. So based on 770 euros, which is every yearly heating bill in Germany, if we reduce the bill by 30%, we get a return on investment in 5 years. But these kind of devices mostly lower the energy consumption by 20 to 40%. So about our development, we need €500,000 for software development, hardware development, testing, and distribution.
So for the product lifecycle, we started developing at January 2018, developing the first prototype, and in April we started crowdfunding. Between June and August, we finished our crowdfunding and development of product, and it's tested already. So in September, the production of the whole system starts, and between January and February, we start shipping to our customers. For our future expansion, we would like to fix any flaws and bugs in the system and make the more efficient system, and create a system for buildings and industrial facilities. And that's it from us. Thank you for your attention. If you have any questions, please. Thank you.
Hello. I would like to ask 2 questions. First is your device prepared for, anyways, will your device work without internet connection? Because I understand that it's not.
Yes, it will work, but just a minute. I need to switch to the slide. As we noted with a small star in the bottom, the device, if there is no internet connection, it will use actually some algorithm that's predefined for normal usage of the system. So it will get the basic values that are, for example, for that kind of period. So something will be included, some simple algorithm for adjusting the home. But we actually recommend using of internet connection.
Okay, so it can be used in remote locations like in the woods or something?
Yeah, it could be used, but it won't be the full potential.
Okay, I understand.
We have the SIM card option though. But
okay, thank you. Second question.
will you provide your own algorithm for NLP, or will you rely on external, for example, Amazon to provide Amazon voice services or something like that?
In this example, we decided to actually use some systems that are already existent. So we're not going to invent that part of the system. So we will probably use some commercial ready solution.
When your product is on the market, if you are planning to continue using external suppliers of software parts like NLP, or will you rely on your own in-house system? And if so, how will you tackle the security of data if you are sending all the voice recordings from the houses to the external part?
Well, it's always cheaper to use the already existing solution than to create your own. So for the beginning, we can use the already existing solutions because they're much cheaper for a small company than to invest all that money into one product, into only like natural language processing. So at first, we would use the already existing solutions because they're already pretty good.
Yeah, thank you. Thank you for your presentation, guys. I have two questions. For example, first one would be in the costs of your device. You mentioned that the main unit is going to cost 150 euro. So my question is, where does this price come out of?
We saw how much current products cost on the market, and they're usually from 115 to 250 euros. But we think that the main unit should be the cheapest one, and the revenue should come from the extensions. Because people usually see the main price, and then depending on the size of their house or room, they need to buy more of extensions. So that's why the cost is that low.
It's your estimation based on other products. Okay, fine for me.
I'll ask about the hackability. You mentioned that it will be for hackers. So it's do you give them some opportunity to use another sensors or stuff in the house which they already have, or it's just about your sensors and all stuff which you provide?
Well, we wanted to make our product like more open, because the return of investment period is 5 years, and that's a lot. And we want to make for the end user, like we want to add them more value by giving them an option. So after 5 years, they can extend our product, and we extend those products by innovations we get from hackathons or from our own engineers.
And now for the 60th presentation, we have Team Alpeadria. So may your presentation start.
Yeah, hello everyone. My name is Omar Douaji, and we are the team Nuremberg Silicon Valley. Today we're going to introduce you the Honeywell Breeze. But before we jump in the idea, I want to cover up some some current technologies. Okay. First of all, the conductive way. Sorry. So first of all, the conductive way. It's the floor heating, and second of all, it's the thermal detection air condition. Actually, the condition manage itself according to according to the temperature of our body. Then we can make it much smarter by connecting it to a smart home. So examples for the problems for air conditioning. Actually, we wait approximately like 20 minutes to the room to get its adequate temperature, and also 20 minutes for the body to manage its right temperature. So, for example, in the summer, when we feel like too hot, it takes us several minutes to get the temperature to cool up. And at last, the car experience. So when we just stand outside the car, we feel like cold or hot. So in the moment we get in the car, we place our hands against the air condition in order to get the amount of temperature that we want as soon as possible. Actually, sorry for stealing the picture, but we made it in purpose in order you to figure out the difference between the old one and the right one before my colleague Gezan continue with the new idea.
Okay, so I don't think it was really hard to find the difference between this picture and the other one. It's these weird-looking dots on the ceiling. So the reason for that is because in order to solve the three problems that Omar was talking about with air conditioning, we wanted to invent our own system, which is the Honeywell Breeze. Now, the Honeywell Breeze, we're really confident that it might revolutionize the system of air conditioning, so please fasten your seatbelts. Before we talk about the system and how we designed it, we want to talk about the things that we changed from the traditional air conditioning. First of all, we changed the piping systems and vents. We changed the surface of the artificial ceiling because, like you saw, it has dots now. And we used many switches and valves, of course, with small diameters and small capacities. So this is a humble design of our project. The dots are actually holes in the ceiling. These holes are actually closed at all times and opened accordingly. They're closed and opened with the help of switchers, which are connected to the main computer of the smart home. And when there's no computer, we can install one. Now, these holes have small diameters and are connected to pipes connected to the main air conditioning unit. There will be also valves there to control the air pump to the pipes. Now, before we explain the functionality, I know everything is now unclear, but there will be examples. Before we explain the functionality, we want to talk about how will this be controlled. This can either be controlled by the computer itself or by the person. Now, the person can select one of these three modes or one of the temperatures he wants. Let's talk about the examples finally. Before we do, let's talk about how the system is working. The system will be minimizing the distance of convective medium between the person and the vents, and will concentrate on heating a small amount of volume, which is the person's body, instead of the volume of the entire room. Let's get to the first example, which is the energy saver. So let's say we go into our home, freezing from the low degrees outside, and the camera sensor detects us and finds our location, and probably in the future expects us at this timing. So the holes, it gives commands for the holes on top of me to be opened and for air to be pumped to these holes. I will be feeling the warm breeze on top of me and instantly due to the small convective medium, and I will not feel the temperature difference between me and the rest of the room because of the boundary layer around me. Now, this is energy saver because only the person is heated and not the entire room, so I'm saving energy. Of course, when I'm moving forward, the camera will be detecting my movement and opening holes in front of me and closing the holes behind me. Going to the next mode, which is the soothing atmosphere. Now, in this example, it's the same as the first one, but with the one difference that the person wants the room to actually be warm. So everything will happen the same, but air will be pumped to the other holes as well, but the holes will actually be closed, giving the surface a hot temperature, causing conductive air, heat exchange between the ceiling and the room, making the room warmer. It's just like underfloor heating, but in the ceiling. Now, the third and final mode is the maximum distribution. In this mode, the person can select this mode, or the computer might tell him, you have to select this mode because there's a lot of people in the room, so we cannot just like open for everyone. All the dots will be open in the ceiling, and air will be pumped throughout them. Now, many might think that this is really similar to traditional air conditioning, but actually it's not. We are maximizing the heat exchange area by distributing the air on the entire ceiling, and hence making the room heated faster. Of course, the temperatures might change. Like in 10 minutes, the computer might say, okay, the room is actually warm, so we're going to change the temperature. This is actually basic in today's technologies. Now let's talk about machine learning. Two phases of machine learning, how we're going to use them. At the beginning, we're going to be detecting the movement of the people, the time they come and whatnot, and collecting data. So now we can expect in the future what time he will be at home and prepare the certain measurements. Of course, we will also be seeing his movements in the house and hence marking dead areas. For example, refrigerator, closet, table. These are places where the person is not moving. So now we can also detect his path or expect his path in the room and hence know which holes we are going to open. Now, let's move to the marketing with my colleague Anas.
Okay, so for the marketing strategy, we have a strategy for the potential customers and the contractors. Please. For the customers, of course, our main goal is to give the customers the full satisfaction, so they can be motivated and excited to try our service. So other than having the social media advertising and the TV commercials, we're going to have a huge marketing campaign that can be happening at the beach, city centers, shopping malls. But what makes our marketing campaign really special, our booth will be providing the same technology that we were talking about to give the customers the real life experience for our new technology. And the customers basically will just walk in a real life environment living room to experience the heating and cooling systems. And of course, we will add the goodie bags. We will give our customers like a small fan. We chose a fan, so it's just related to our topic, and so they can remind themselves with our project. Okay, for the contractors really play really huge part for this project. So we will also have the same technology at our stands in the exhibitions, so contractors can test and experience the same real life experience. But other than that, they will have the data that we will be collecting from people during our marketing campaigns. Okay, and the second strategy will be the advertisements. We will have posters on each and every construction site that we will be working in. Okay, sorry.
The approximation.
Yeah. Here is a table for some rough calculation that it shows that. And the sum of our rough calculation is about 2,000 euros for a system for a 10 meter square rooms. So in comparison to a central heating air conditioning system, it's also in the same price, and compares it compares to the technology and also the new experience also with the smart home, and this can promises the new experience for our customers. Yep, this is our motto. Thank you for your attention.
Thank you.
Have you thought about the mechanics of the dot, the switching of the individual dots?
Yeah, actually, we thought of a simple mechanism of doing this. The dots are going to be covered with small plates according to the radius, and with a switcher according to related to a circuit. So whenever they have the command to open the circuit, the plate just goes off and on.
Every dot would have a small servo motor.
Every dot will have a small plate, metal plate, that will be closing it and opening it.
And what would do the opening and closing?
Opening and closing, like I said, it's either we open on top of the person, providing him with heat on top of him, giving him the maximum heat experience, or when it's closed, it can just like be underground heating. So we're heating the surface.
Okay, thank you.
Just like this example in these ceilings, we have a little holes in here, and we just design the first. We just design the holes and also the terminals, and we can call it the terminals, and which connected to the FCU, and the FCU which have a lot of coils, a lot of wires. In our calculation is about couple wires, but we can use about polymer coils to exchange the heat, and so that we can transfer the liquid, and also we can transfer the heat through the holes.
I have another question. You said that it will be also heating, right? So you were kind of saying that this is something like a floor heating. To my understanding, kind of little understanding of it, if you heat the floor, the heat is going up, right?
Yeah.
If you heat the ceiling, the heat will not go down, right?
Yeah, but the heat normally goes up, I know. But when we heat the ceiling, there will be conductive, because due to conduction, the room will be warmer. But when we're pumping the heat, like the heated air on top of the person, he will just feel it because of the small convective area. So it will be, due to convection, it will like move to him.
Okay, good.
Yeah, I got one question about draft risk. Did you think about it?
About the what, excuse me?
Draft risk. It's about speed of speed of air supplying.
Yeah, we actually we had little time for research regarding the technical stuff, the real technical stuff. So we didn't calculate the speed of the air at which it will be pumped.
Okay, it can be the problem sometimes. Yeah.
Okay, sorry. Question from my side, and this is basically like case every time when you have air flowing on you from the upper part. The thing is that from the biological point of view, the points on your body that are like most sensitive to the temperature are the foot and the wrist, or how is it called? Yeah, the wrist. And this is not exactly like up high, because mostly in the contact with the highest, with the hottest or coldest air will be the head. So have you thought about how you can tackle this biological
Actually,
problem, let's say?
I think that was tackled by underground heating, where they wanted actually to heat the feet and then like for the heat to flow over. But we thought that heating underground is actually costing people a lot of money and wasting energy. So we thought heating the person himself would spare us energy with the energy saving mode. And with the distribution, like the last mode, we're going to have maximum heat exchange. So that was actually the point, because I think it's covered with the underground heating, tackling these areas.
So your system would be installed additionally, for example, with underfloor heating?
No, it should substitute the underground heating based on the calculations being better than underground heating. Yeah, of course it will. If you're laying in bed, then it will open the dots on top of you and be heating the bed. That was the point of this, because the bed is not marked as a dead area if you're sitting on it, if the camera detects that you're sitting on it. Thank you.
Thank you, Team Al-Qadria, for the presentation. And for the 7th presentation, we have Team France. You have 8 minutes of presentation plus 3 minutes of questions. Please stick with the minutes. Thank you.
So good evening, everyone. We are with the Team France, Damien, Paul, Fabien, and myself. We are glad to present you the result of our work for the third case study, which is the evaluation of data from home thermal comfort technologies provided by the company Honeywell. So, as you can see, this is one potential website for the new solution we have designed. So, as you can see, we suggest to have some subscription in which for the outsiders, we provide them a third for their energy fees. And for that, we have made some market analysis. So first, we have made some segmentations. Geographically, we're gonna focus on EMEA. We're gonna sell some software and services, and we will be focusing for the residential buildings. That's why we have focused for two specific markets, and we have listed the different the driver, the challenge, and the trend of the BMS market. So for the strategy, as you can see, we have some example here of the trend of the markets with this graph. We can see that we have some the growth of the segmentation, which is represented by the purple segmentation, and we have some small segmentation. That's why we're gonna make a differentiation strategy. And for the benchmark, to have for the direct competitors for Honeywell, they have only open system with the technical expertise and with a backnet access. Sorry, and they provide only solutions for building and commercial. For company commercial buildings, and for the startups, which are for the HBMS, so the home building management systems, they have no machine learning. They provide only hardware solutions for like the Kivivo or the Rin for 350 euros, and they have no open system. So our solution is to mix these two strategies to make another solution for the householders.
Now, in order to better understand why we offer a subscription, I want to show you the principle of our solution. So we decided to equip the houses only with sensors and actuators. The brain of the machine learning algorithm will be in our offices, in our server room, where we can have more powerful server that can process a lot of data from all houses in order to have a good adaptive model of the heating house. So the data are sent through internet from the house to the server room. Then the machine learning algorithm run on these servers, and the command for the heating, ventilation, and AC are sent back to the home to the regulation. One other advantage to have this server room separate is that it's easier for maintenance, and if you have a problem on the server. So we can access directly and avoid having days for any fixing of the server. You can also have an application on your phone where you can set every references for the values and control manually the heating system. Now, in order to have some strategy, we established a SWOT matrix where you have the strengths, weaknesses, opportunities, and threats. So in a nutshell, the threats are mainly the new startups and large companies that can also use machine learnings, but we have to be also careful for hackers, since we will use internet connection. And for one of the weaknesses, for instance, is the internet dependence of the solution. So thanks to this matrix with strengths, opportunities, we can have a list of strategy that you can have. You can read all of them. But I can give you the example that you can overcome an internet issue with, for instance, GSM server, so that there is no problem, and have some backup mode with simple controller if there is a situation with the machine learning algorithm. So now I will let Paul explain a little more about the financial benefit for the clients.
Okay, so we approximate the cost of energy for a house for a month at 133 euros. So that's for Europe. So with our technology, it's possible to save up to 30% on the energy bill. So it represents 40 euros per month. That's why we decide to choose the price of our services at 20 euro per month plus an installation cost of 100 euros. So that's a fast return on investment of 5 months for the client. Here you have the business model of our company. So you can see on this Excel sheet on this drawing, the company start to earn money after 14 months. But this estimation, it's based on three things. Sorry, the estimation with 10 employers, 100 new clients per month, and no loan at the beginning. And no, I will give the talk to.
We use machine learning to manage the energy atomic system in the house. So we use a k-nearest neighbor method. We have training data here in blue and yellow. The method consists in drawing a front which regarding which neighbors have any point, and decide the classification of the point. So you can choose a number of neighbors, but it's so little, very little, you have overlining, like in this curve, with a lot of data in data and training sample. You have overlearning and a lot of errors. And if you have a big neighbor, you will smooth the curve and it will not precise. Next one. So we can use this for management in energy and thermic management on house. With this curve, we can show the power consumption of a house with the time. And here, with the variation, like here, we have a big variation. It can correspond to an oven element according to a database. So we can recognize the electrical use from energy and predict the electric consumptions. So in conclusion, our project is provide new services with an innovative business model, the possibility of market from leading some ICBM and some innovative technology with the data center to manage the technology and a fast return of investment. Thank you for your attention, and now it's time for questions.
How did you consider the extreme situation, like the storm is coming with rapid decrease in temperature and the internet is out?
We have a GSM system to replace the internet system if we have no connection to still control the home.
Thank you.
Thank you for your presentation. My question is towards the sales part. You were mentioning that your return on investment is only 5 months. My question is, why is 5 months is quite short period? So why have you chosen this price for your device? And secondly, you are mentioning that your device can have up to 30% of saving on energy bill. So my question is, what is the comparison? What is the benchmark?
I can answer for the second part of the question. So for the benchmark, the 30% was an average of the state of the art for those kinds of building management system, especially with the KVivo and the Win solution. That was the percentage they gave. That's why we choose the 30%. And for the first part, it's up to you.
Yeah. So we decide to speak about 5 months. It's because it's, I think, very short, because the installation of a house take more than that. When you start to manage to go in a home, you take more than 5 months to be really installed. So it's very short if you look the whole process to start a life in a home, in your new home.
And could you show the slide with the cost for your companies? I would like to ask you, what is the unit? Because I know.
Yeah, sorry, it's only in euros.
Okay.
Yeah, the first two one have no unit, and the last one are in euros.
Okay.
So it's normal. If we don't make loan, we start to lost money, because we have to install all the equipment, and after 14 months, you can see we start to earn money.
Test. Okay. Second. Okay. And after a short break, we continue with the 8th team, Team Baltic. So may your presentation begin. You have 8 minutes of presentation plus 3 minutes of questions.
Thank you. Ladies and gentlemen, good evening. We are team from Moscow, Logic and Logistics. So allow me to actually introduce my team. The guy in the yellow shirt, Oleg, our fearless leader. Without him, we couldn't be called actually a team, because he organizes us, he gives us tasks, and he actually makes us human beings. This charming lady, Eleonora, is our technical and managerial expert. So she actually tells us if our dreams can come true. Tatiana, the master of presentations and design. Well, what can I say? Beauty can save the world, right? So, and I, Vitaly, a linguist and engineer in one bottle, but connecting people anytime. So actually, as you may understand, well, any task that is connected to comfort is very, very complicated. A lot of engineering thinking, and actually must be simple and handy for our customer. So we decided that it requires two things. Firstly, it is a lot of financial and maybe economical researches, and secondly, the bright ideas. Well, we got both things, so let's get started.
Coming straight to the most important parts, need of our customers. What do they need and why we are what they need? We understand what is valuable for our customers. Comfort for everyone, friends, family, colleagues, and ourselves. Reliability. No one likes to call repair centers and pay them money. And any system should be profitable. In our case, comfort is our profit. Your comfort is our reward. To achieve it, we have designed a way to create a flexible microclimate by combining traditional air conditioning with smart technologies and Internet of Things.
But to get this idea, we actually have to understand what are, well, traditional air conditioners. Well, why these traditional air conditioners? They're reliable, right? They're not really complex, you see here, and they actually can be fixed like at any place around the world, in any center of repairing air conditioners. So here is the actual scheme that shows us how air conditioners work, and I would like to invite you for a small excursion around the way of Cooper tubes around the whole air conditioner, because this actually makes our days cooler. So let's start from the very beginning, where compressor has its outlet and the refrigerant inside it is of gas form and very hot. It goes to condenser, right? So inside the condenser it gives away like a lot of heat and also becomes liquid. Then it flows inside the very small but important and very crucial part called the measuring device. Well, actually, measuring device is quite often presented as TXV, thermostatic evaporation device. So yeah, it goes straight to the evaporator, where the liquidous refrigerant absorbs a lot of heat and becomes of gas because it has boiled. So then we go straight to the compressor again, and so our excursion is finished. So inside it gets pressured again, so high pressures. It's high pressure and of high temperature again, and yeah, here we go again, right? So actually, why is our solution unique?
Firstly, it has a flexible system for offices like this selling model, or for homes, apartments, or restaurants like wall model. Moreover, our solution is finally compatible with smart home systems, so it can use all the data from smart sensors and predict customers' desires. Now, AC unit is mass as well. In addition, our system is a part of Internet of Things. Specially designed application for modern smartphones allows customers to select different modes, such as sport, work, relaxation, or automatic mode. For example, sport may require special conditions or any kind of activities. Combining the functions of system, you can use the mode that suits your mood. It's individual for everyone.
Okay, to start a successful sales, it is important to perform a market research. Firstly, we need to define a target group. We have three of such groups. It is house, apartments, and offices. Our air conditioner can work in smart house system and can be connected with other devices through Internet of Things for advanced control of climate. Secondly, to define a potential leading product, we need to perform segmentation. Having defined degree of devices for cooling and heating, we can see that smart air conditioning it is the best It is the best way which should be highlighted.
Then we will define possible sales channels. We sell through internet, intermediaries, and own our sales outlets with after-sales service. For each of these channels, there are possible scenarios that you can see on this slide.
Here you can see costs for production. It includes main details of system. This slide leads us to total calculations of fixed and variable costs. For production of items, we need some extra money in order to pay salaries or to buy additional details. Finally, I would like to explain you diagram of return of investments. The line of total costs starts to rise from points of fixed costs until an end of planned period. Another line is revenue. It starts from zero and goes up to planned revenue. The expected price is €942. As a result, the diagram shows us that we need to sell 118 products in order to go through breaking even point and start to get a profit. Now it is clear that the idea can be realized.
So actually we have finally finished our presentation almost. The last part is there, you can see extras. And this is, I must say, one of the most crucial parts in like any presentation, because it is thanking you. Because you actually gave us the possibility to use our knowledge to actually show you that we are able to perform a lot of calculations and show you that we know how to use the knowledge that you provide us with, that we can actually have. So thank you once more for this opportunity. Thank you. All right, now it's question time. If you have any, just ask. Sure, of course. So we actually use the smart system in order to get all the information. Please, can you get to the smart systems? So our air condition unit actually is installed inside the smart system. It gets a lot of information from the smart sensors, and it can send information to both directions, to user and to the cloud. The cloud is the place where all the calculations are performed and can be used for later, well, let's say, future analysis and maybe preset mods for the air conditioning. So that's it. Yeah. Well, yeah, thank you for a good question. It actually, well, this system is quite perfect, you see, even too perfect. We would also like to include that we need some, let's say, extra materials for it and some starting point. And I can't actually say that it will be so profitable at first, and it actually requires some extra researches and stuff. But the point is that this is a very possible idea, and so yeah, if you want to use it, just take your chance. Thank you very much.
And now for the 9th presentation, we have Team Poland.
Hello everyone, we are team case study from Poland. My name is Mikołaj, is Radosław, Grzegorz and Jakub, and we are all from aerospace major. Let's talk a little bit about strive for energy saving. We notice there is a problem. Energy efficiency of house is getting better and better, but it's lacking a true revolution over last few years. What has been done so far? Basically, we can say existing solutions are heading in two different directions. First of them is individual sensors that can be put into each room to control temperature. And the second upgrade of that is the computer, which is managing few of sensors like that in the home. Another solution is based on much simpler sensors, but able to exchange data between itself. It's like Google Nest, which energy saving efficiency is between 10 and 12%. And the previous one I talk about is like If Home, which energy saving efficiency is between 20 to 30%. So what if I told you we can get up to even 40% with our solution? This is a big leap forward. We decided to get best out of both worlds. We present to you Honeywell Home. It's based on specialized sensors, net combined in a wireless ecosystem. Its features are, it consists of wireless devices, which are modular, so that you can add another sensors to existing system that you have. It's made out of different components that are delivered by a lot of companies in our wireless system standard. They are able to exchange data between central computer, not only information about turning on and off. And we also provide combined measurement unit, which is developed by us. It's very small, very cheap, and can be used in every room. And it measures temperature, humidity, CO2 level, and so that it also gives information about the quality of the air in the house. What about thermal control? You have CMU unit that I talked about, thermostatic valve, window mechanism that enables to open and close the windows automatically, as well as window blinds. We have wireless vents, weather station, in which I will talk in a moment, and many, many more. For example, air conditioning on different climates. There is a central computer which stores the data, send it to the cloud for the further computing, and connecting all devices in the home. It's easily upgradable by the internet and controlled by our app. And finally, there is an algorithm developed in the cloud. It allows to manage your home smarter than ever before. It's based on machine learning and all the data provided, previous week, month, year, creating patterns based on inside and outside condition to fit your life perfectly. So for additional input, you can get the weather forecast. You can put in isolation you're using in your home, room area to make the calculations easier, and also information about surroundings. If you're living in the next to the lake or forest, it also influences. And holiday mode, so that the home know when you're out of town. So what about develop? We are developing our algorithm based on your habits, like going to work, adjusting everything, remembering your adjustment and repeat it. Weather check that I mentioned, and also comparing it to the weather station that I mentioned. Upgrades that we talked about. And data exchange between the homes in the nearest neighborhood, so that your database about the area you're living is the best. So about costs and business plan. We estimated production cost of our system for 1,130 euros, and it's for semi-detached house with 3 bedrooms, 2 bathrooms, 1 living room, kitchen, and a garage. The final cost for the customer will be around 1,500 euros. It will get back like around maximum of 8 years. So target group is very wide. We are able to provide our system both to old houses, new houses, and because it's scaled up easily to bigger facilities like schools, markets, and so on. So it's basically for everyone. We decided to go globally, so we are using business-to-business system. We want to work with local distributors of existing smart home solutions using our algorithm and devices with this wireless system we talked about. So in this way, we are cutting costs and we are able to focus on an algorithm itself. Here is the Gantt chart, which is also provided in the report. And as you can see, we'll be able to launch our product on the market after 2 years, which is very fast. So, time to wrap it up. In our system, it's a new way of thinking best out of existing systems on the market. Its wireless modularity is its biggest strength. It's another level of quality for the saving energy, efficiency, and quality of the air in your home. It's constantly improved by our algorithm, and it's first truly intelligent system that fits you. So why not live well, feel well, and save well with us? Thank you. So we decided to base on data storage not only by all the systems and devices we are using, but also by predicting the future behavior.
So the machine learning, it's based on past data that the system gathered, and it makes conclusion out of this data, and this way predicts the adjustment for the future events. We predict what temperature is just fine for you. We predict the humidity that fits your family. We predict the wind flow through the house, that you are not too cool and you are not too hot. No, it's just to make you more comfortable in your home.
As well as the surroundings of your house, like weather, temperature, wind, shades that are covering your house, etc. So the algorithm will know basically your house and surroundings to fit your needs. We're predicting what's going to be like in a few hours, because we've got the net of all the houses exchanging data.
Well, so every sensor has its own power source, and it connects wirelessly by Wi-Fi with this central computer, and it sends the data it gathers to, Well, this business-to-business program, it takes this weight of maintenance off of us, because the outside companies are responsible for it. And what was the other part?
For example, how long would it take for your product, wireless and
basically with the photovoltaic batteries, we were thinking about connecting it directly to your circuit in a house. Basically, like you can just plug it to your socket or use like lights and have another cable to connect it. So. Once again, please. All right, so we have this central computer unit, right? So it's doing all the control of the sensors and the actuators that are setting the, for example, window blinds. And the cloud computing, it's only for machine learning. Yes, that's our like the safe feature, because if the internet connection is bad, it still can control all house.
Thank you, Team Poland, for your presentation and answer. And now with the 10th team, Team Portugal. So may your presentation start.
Thank you. So our team name is The Firm. We're from Portugal. We're going to present our case study on the evaluation of data from home thermal comfort technologies. Next. Okay. So we are going to present the design of a sustainable and efficient hydroponic system, the recognition of a current hydronic systems problems and incorporation of some proposed solutions, the determination of necessary equipment and sensors, data analysis methodologies, also going into an economic analysis and also marketing and sales channels, and the end, some introduction on the life cycle of this product. So, our hydronic system design is basically a classical one, but we introduced some differences. There's a geothermal manifold station, so that to increase the efficiency of the system, because underground the temperature is relatively stable throughout the year. And to heat or cool the water, we're going to use a heat pump, which then transmits the water to the several heating or cooling stations. Next. So, some typical hydronic systems problems include the slow heating response, also some stagnant air inefficiencies, water solidification due to heating malfunctions which can burst some pipes, and also the expensiveness of the solution. To tackle these problems, we suggest an additional underground piping, the geothermal manifold station that I talked about earlier, and the addition of a ventilation system to tackle the stagnant air problem, and also the inclusion of a temperature sensor in the boiler as to prevent the occurrence of the water solidification due to heating malfunctions. The necessary equipment for this model was based on a household with 60 meters square, 2 bedrooms, 1 living room, 1 kitchen, 1 bathroom, and 1 hallway. We implemented the Honeywell Evo Home centralized thermostat, which has wireless capabilities, which allows the communication with the temperature sensors and with every other sensor, so that it permits the zoning of the house. Each room has a different temperature. And we introduced also 6 temperature. I'm sorry to say that the EVO Home also has an app that can be used to control the temperature in every room. We also like to implement 6 temperature sensors, also humidity sensors, infrared sensors that permit seeing if a person is entering or exiting a room, as to put a different set point if the person is or not in the room, and also door and window lock sensors to see if a door or window is open and do a corresponding action. And also 6 microphone systems to take advantage of the existing voice recognition software that has been developed by Honeywell. The bedrooms and living room are heated from the floor, and the remaining rooms use wall radiators. This solution is highly scalable and modular because you can implement just the heating system or retrofit the technological solution to an existing system.
When it comes to data analysis methodologies, we decided to implement a cloud that is owned by Honeywell. Of course, it has computing power because it is much greater than computing on spot, as well as incorporating machine learning features with the usage of algorithms such as principal component analysis and cluster algorithms, which can work in a supervised or unsupervised way whenever necessary. And of course, it means that we can have data sharing features as well, because all of the information that is produced by the households in a certain proximity is then condensed in the cloud, and the algorithms can use all of the information in the proximity to estimate and to adapt to customer necessities and better cater for those necessities in the specific area as time progresses. When it comes to our economic analysis, we tried to incorporate prices of the materials that are required and estimate 3 possibilities. First of all, we decided to use the pricing of the equipment as one possibility. As a second possibility, the price of the smartization of the house, so the sensors and the data analysis tools. And thirdly, the implementation of both systems together. I'm very sorry to say that we didn't actually have time to upload the final table to this model, but the only difference is that in the end we actually ended up with 3,800 euros here, 1,500, and the final total price of approximately 5,000, which means that our break-even point for Honeywell selling this kind of service would actually be around 4 years and not 5, which is very good news for Honeywell, of course. And when it comes to marketing and sales channels, when it comes to our markets, we would focus on the markets that Honeywell is primarily using already, so United States and Canada, whilst focusing as well on emerging Asian economies such as China and India. And of course, we wouldn't discard positively regulated countries such as Europe, because we know that in European countries there's a lot of regulation being passed on energy efficiency, and as such, doing business with such an efficient system could actually benefit Honeywell by making Honeywell applicable to receiving special EU grants, for example. And of course, our solution, as João already mentioned, would be very modular and very easily scalable, which means that we could apply to households as well as commercial buildings. And finally, when it comes to our sales channels, we would continue using typical Honeywell sales channels as retailers and online shopping. And as a final comment, when it comes to retailers, we know that Honeywell sales through their online shop and retailers, but we also know that most retailers sometimes are averse to selling this kind of smart technology, because they actually realize that selling that smart technology can expose the flaws of their own non-smart equipment. So as a long-run measure, we would actually further incentivize Honeywell to sell their own material without the usage of retailers. And when it comes to our final slide, life cycle, of course, we would begin with the product production, which begins at Honeywell, of course. It manufactures all of the products, and then the product is made available to third-party retailers, as I said, with our suggestion of phasing out those retailers in the long run, or are directly sold to the customers via the Honeywell website, which is very good. When it comes to the installation, the third parties make the installation. And when it comes to the operation, Honeywell would continuously check on the quality of the product by checking the data and analyzing the data that is made available through the Honeywell cloud, which means that Honeywell could actually further complement the service for the customer and make it more efficient as time went by. And maintenance, the same thing. Data flaws could be very easily detected via the massive information that is in the data that could be analyzed. And finally, when it comes to the disposal of the product, Honeywell could actually check for a possibility of renovation of some products and other applications, reutilize those and dispose of the rest, obviously. And that concludes our presentation. Thank you for your attention. If you have any questions, we would be more than happy to respond. Thank you.
So you can use principal component analysis to, if you have a training set, first to develop the model, and then to using the data. For example, if there's a particular event and you have all these variables, you can extract significant information from such model that you are continuously training. For example, if a person, when a given number of variables are being measured and for 1 or 2 times changes that manually changes the set temperature, the algorithm using that data can understand that if those variables, the number of those variables happens again, that person would have that, that action, and then can do that without the person.
Well, clustering algorithms are very useful to sort data so that it's easier to... Well, because we are, as we know, there's a lot of sensors that measure a lot of things. We mentioned temperature, humidity, etc. We can collect all of the data, and we can see, and we can cluster the data in significant clusters of information, which we can then analyze and see the patterns to which cluster represents. For example, when there's specific temperatures and specific actions are undertaken at specific temperatures, and we could agglomerate all of that information in clusters, so to make easier to manipulate the data itself. Thank you. Well, it's actually, I think it's, since we have a very modular approach, and it is very scalable, because we could simply increase the number of sensors or the number of radiators and the number of, for example, boilers, which means that it's very applicable to a very wide scale. It was primarily designed, as in our case, for a 60 square meter household, a typical T2 household. But it could, of course, be scaled to houses with similar or approximate requirements. So, for example, museums, offices, etc. We would say that it wouldn't be suitable for example, industrial compounds, because they require very different sorts of energy with very, very different powers and etc. So everything that is not industrial, it could be implemented. So our estimations on prices? Yeah. Well, as I mentioned, some of the values here are outdated. We then changed some of these values, but we didn't really have the time. So the Honeywell thermostat, Evo Home? We actually took it from Honeywell's website, online shop. Yeah. Yes. Thank you. Thank you. Thank you.
And now for the 11th presentation, we have Spain. Good luck.
Thank you. Sorry? Yes, we know. Okay, so good afternoon. We are Albert, Uriol, Maria, and I, Sergi, team of engineers, presenting our project Yard Heating on the future of home thermal comfort. Now, energy thermal management is one of the is a crucial market in Europe, representing 50%, about the 50% of the energy consumption. And although historically only heating services were relevant in Europe, the trend has changed, and now cooling services are becoming more important. And some predictions state that by 2050, the cooling services will actually be more important than heating ones. Now, we're proud that all of our works follows like the European Union energy saving guidelines, like improving building envelope, recovering waste heat, using renewable energies, and so on. Now, after carefully thinking about targeting, we realized that in order to deliver the best user experience to our clients, we needed to take full control of their systems. Now, we faced a problem because most of the people are actually sufficiently comfortable with their already owning systems, so they're not willing to justify a high investment to redesign them all. So we realized that targeting building companies was actually a more preferable idea, especially in the long term. And for a little incremental cost compared to a regular installation, we can provide a unique added value that will be very important in order to sell new dwellings. And moreover, long-term partnerships and with a good product, we can position ourselves as leading providers of home thermal management solutions. Now, what is the market size we're talking about? Here we have very quickly a graph of new dwellings and modernized ones only in Czech Republic, and it's about 35,000 combined ones, which is promising.
Yep. Although thermal comfort seems a really trivial issue, it depends on many factors. So, apart from personal preferences, there are metabolic rates factors. So, for example, if your heart rate is really higher than usual, you probably might prefer a lower thermal temperature. Also, if you're wearing warm clothes or solar or summer clothes, then it also takes into account. There also play a role like the environmental factors, which it's really easy to see. If outside it's really cold, we might prefer a lower temperature in our house, or the opposite. And there also plays some role the physiological factors, which Maria will explain later very briefly.
So, okay, with so many different factors and so many of them being subjective, how can you actually predict the thermal comfort? So the truth is now there are two different models that serve different purposes, because when you enter a building, your expectations can extremely affect your thermal comfort zone. So in the first case, for AC buildings that you're expecting it to be AC or you know that they are, the thermal comfort zone falls within a very strict range and is mostly affected by humidity. However, if you expect the building or you know that it's non-ventilated, the thermal comfort actually kind of adapts to the outdoor temperature, so it has a wider range. Bearing this in mind, and knowing that these two different models are very hard to fit right now, what can we do? So we based our strategy on sensors because they allow us to evaluate the thermal comfort in real time and also to kind of forecast the weather conditions. So if you know, if the house knows that it's going to be sunnier later, it's going to start to prepare now. So our ultimate goal is to anticipate the changes and to needs. And how are we going to do that? How are we going to treat the data? We're going to do a machine learning approach. And the first step for that is to do what is called attribute selection. So we're going to do like a beta test with picking several houses and putting a lot of sensors on them, and then asking the people inside to evaluate the thermal comfort. Then, after a year, we can use this data to select the most relevant parameters of the model and only use those sensors for our services. So in the houses that we're going to serve, put only the most important sensors. And then with that, we're going to be able to construct a personalized predictive model for every single person. So the first few weeks, the house is going to learn what do you like, and for example, what clothes do you usually wear, or your morning routine, or how the weather outside affects inside. And with that, you're going to have the perfect temperature all day long.
So the first thing we have to do if we want to do an official thermal system is to calculate the heat loss. So we did some calculations that you have in our report, and the heat loss came the most part on the walls, but also one part on the windows. Here we have like a small graphic just to see that if the temperature outside it's around 2 degrees, we will use like 3,000 watts, and if the temperature it's much higher, then we will just use around 1,500.
Well, my partners explained the project, and now I'm gonna break down into steps, the steps we're gonna follow to make it real. First of all, we have the data acquisition test. This is gonna be our beta phase. Afterwards, we're gonna go for the attribute selection, which Maria told you before. Then we're gonna contract with the sensors company when we know exactly which ones we need. Afterwards, we're gonna create the model, and then finally we're gonna contact with the building enterprise in order to sell our product. Then we're gonna have our first round of installation, and we're gonna get some feedback. With this feedback, we're gonna elaborate a better product. But this is not the end, because we're gonna have another round of installation, and we're gonna get more feedback, and we're gonna improve our product, and this is gonna be a never-ending story. About the price, we make the numbers, and we think we can build our project for 12,600 euros. Then we can raise a little bit this price and have earnings on each of them. And we also saw that in Czech Republic there are 21,000 buildings built every year, so we can have like a relative short-term payback. So we're gonna earn it's 10 million in 1 year. And finally, we need to think further on in the long-term future, and we think that the wearables are going to be the next revolution. So whenever all the population have wearables, we will have more variables to study. Then it's going to be really easy to know where is everyone in the building, and also it's going to be more personalized. Děkujeme.
Yeah, we'll keep it.
This one?
No, the one before.
This one was simply
would be like a better program testing for this. So we would sell this service for like lower price than original and use, for instance, all the employees' houses and other these kinds of stuff. The main idea.
Sorry, the what? Yes, to be able to predict the thermal zone of each person according to, for example, the time of the hour or the sun that is getting inside the room. Because it's not only, we found that it's not only dependent on temperature and humidity, it also depends on a lot of other things, and then we would try to use as many sensors as we can and then find out what is really important about it.
Like the first, like I think like the first step of machine learning is the attribute selection, where we like examine a lot of variables and then we just choose, I think it was 3, the most important one, like the 20% top, which have the 80% effect, and based on that creates a model to replicate the effects in the.
No, it's when you're a new customer, then the house can build its own model according to your personal tastes, to say it somehow. And that's what the machine learning would be used for, to make a model for every single possible client. So the features would be these, the previously selected, yes, because we think that would be the more relevant, but the way the model is constructed would change. Thank you.
And now the 12th presentation will be delivered by Team Turkey. So may your presentation start. Bear in mind you have 8 minutes of presentation plus 3 minutes of questions. Good luck.
Thank you. Welcome to our presentation. Today we are going to present our product of thermal comfort technologies from Honeywell, and we are aiming to have stable, reliable, long-lasting, high quality and efficient HVAC system, which is controlled by cloud-based self-learning system. Our system consists of different kind of subsystem of heating, air conditioning, and ventilation. My friend will talk about that. Our system has different kind of sensors, such as humidity, temperature, pressure, motion, light, enthalpy, carbon dioxide, gas detector, dust detector, etc. And there are two main purposes. The first one is they are used indoors in order to give feedback and inform the controlling system about the condition. And the second one is they are used in RV system in order to screen the processes and to be able to define the problems. And as I mentioned, we have controlling system which receives the data from sensors and operates them and adjusts the system accordingly. So what we offer we offer a user-friendly mobile application system, which end user can set the conditions. We offer to end users reliable and rapid responsive system. And in order to have this, we use two controllers in order to not have interruptions when the first one is down, and we use special room design, special design of several customers that advantages of health and efficiency. For example, it is stated that temperature level of bedroom affect the quality of sleep. So we built underflow heating system in order to provide uniform heating. We provide low level of indoor air pollution because indoor air pollution is 5 times more polluted than outdoor air, and our customer satisfaction is very, very important for us. So we offer technical support, immediate response, and perfect maintenance.
You can see here our representative figure of our system. Here solar panels provides low-cost energy to our integrated system, and solar heat pump boilers transfer heat to our system. By the way, solar heat pump boiler and our computers must have their backup systems, as if there is unexpected situations in their processing. Here our master system, which includes thermostats and various sensors that enables us to monitor our system continuously. Thanks to our main computer and its results, we respond to extraordinary situations immediately. And lastly, the basic logic is made up of combined open and feedback loops that optimizes our responses. By the way, note that we should consider European Union's energy and climate goals and also IOSE standards throughout the project.
Thank you. I'll be talking about the machine learning process. We'll be using supervised learning methods since we have some outputs such as temperature and humidity, etc., given some inputs like flow rate and temperature of the water entering the room, temperature of the environment, weather conditions, etc. So we'll need to build a model that will be able to explain the relation between these, and that will be able to predict the future outputs. Therefore, we are using this method. For doing this job, we will be using multivariate adaptive regression splines. We'll be modeling the system and trying to, our computer automatically will be trying to fit the best coefficients into this regression. Therefore, we need our computer to be able to analyze the inputs and outputs very well and include and exclude the parameters which are needed to the regression model whenever it's necessary. And also, now that this regression model will be updated whenever new data is available. So that was about our product. So next, I'm going to talk about marketing. So the most important value proposed by us to our customers are the reliability of our product and our relation to the customers. Also note like quality of life, increased quality of life, and easiness to use of our applications. Therefore, we need some customers that will be willing to pay for this, and we think that the middle and high income classes of the society will be able to pay for this, since they don't want to install and have some problems with the system. They want a good, reliable product that's working without some problems. And even if there are some problems, it will be solved immediately by technical support. We'll have a good technical support, as my friend stated. As I said before, the customer relations is very important for us, so we'll have like a very good one-to-one customer relations. We'll be able to help them whenever it's needed. The next important point is the channels that we are going to reach our customers. The most important channel for us, it's so-called power of words. That means we want our customers to be loyal to us in long term, and we want them to speak about, to tell about our product to their friends and families. and therefore that means we want the long-term relations with them. We'll be using like lots of other ways, such as malls, billboards, and construction companies, etc. Also, I want to note that there should be small tricks, such as maybe, for example, we'll be finding the barber shops as our first customers, elite barber shops, so that they will be talking about the customer during their work, so others will listen and listen forcefully, and they will be hearing about this. And the last but not least point is about the price, revenue, and the return of investment. We expect our price to start from 4,000 euros, and it will depend on the size of the project. As I said before, loyalty of our customers is very important for us. Therefore, our return of investment can be some long time, such as 7 to 10 years. It depends on the fixed cost of the building of the software and hardware. So that's it for it. That's all. Thank you. So if you have any questions, we'd like to answer. Thank you. Thank you.
From Team Romania and Republic of Moldova. Good luck. You have 8 minutes of presentation plus 3 minutes of questions.
Good evening, everyone. We are Team Ideal, and today we are going to present you our smart house, smart heating system.
The problem we are trying to solve is that you unevenly heat your house using traditional heating systems and lose a lot of money while trying to tune it.
So we tried to find our value proposition. Our value proposition for our product is optimize power consumption and increase comfort. For who? For heating system owners and users from European Union and from the United States. We find that our users need fast troubleshooting, need to keep their existing infrastructure, need comfort, need scalability to their solutions. So we tried to aggregate data, to have a specific approach in order to integrate in an effective way the subsystems, and we created value for our customers, such as real-time control, architecture adaptable solution, comfort increasement, money saving, effort saving, and effective pattern-based decisions. You can see our pain relievers and our pains we found, and also our product and services. And the main product of our team is a standard smart thermostat with extra sensor modules that could be added to it. So we will have smart control units and cloud-based control panel connected to it. We can you can see our sensor architecture. It will be modular. You can connect also an Alexa or Google Home-like interaction module in order to connect it with your smart home solution. It will talk via Bluetooth Low Energy with an adapter that can be connected to your chiller, your standard gas heater, or to your BMS of your choice. No matter how smart your building is, our solution is adaptable to any building and any system. All right.
As for innovation, we will have the following: Wi-Fi based house mapping, modular sensors, scalability, cloud integrated IoT integration, data aggregation, which means we will factor in data such as the outside weather forecast, your personal experience, preference, and available resources. Also, we'll have model sharing, which means our system will look for similarities, and when it finds one, the less experienced system will learn from the more experienced one.
So the controlling system are the following. Our client set the temperature inside the room, and also is here we have machine learning, a sub-machine learning that will use a BET algorithm to locate the place in the room, and that one communicates with the general machine learning that have access to database where we collect the other information, and each subsystem send information to the heat and cooling system on our house and on our home to provide what temperature we want.
So the goal is to be able to command everything from any kind of heating system or cooling system. We would like to make it scalable from heat exchangers to boilers to dual wave valves and to even chillers and air exchange units. We would like to make our system as effective as possible by saving energy while you don't need it. You see here we have integrated also renewables, which have a random pattern of producing thermal energy. And as we said, you as a customer set your options. We, with machine learning and with weather prediction and with learning your house pattern, try to fit into your budget, into your set budget, in order to give you comfort, in order to set up everything in your home. And maybe you've heard of Wi-Fi based positioning inside your home. We would like to use only one sensor for medium homes in order to learn your whole house pattern, and your sensor could travel from one room to another and stay there for a low amount of time, like 2 days or 3 days, in order to learn that room's pattern. So our system is very, very interconnectable. But what about the money?
We have like 3 different types of homes we would like to address and buildings. First are the smart ones, and for those we will reduce consumption. We would optimize consumption up to 50%. For homes that are not that smart but they are like modern, we would optimize power consumption up to 25%, and for the ones that are more rustic, up to 15%. This actually reduces the costs too, and the price for our model varies between $250 and $60. It depends on how many modules you add to your standard thermostat. We also did a SWOT analysis in order to determine whether this is viable or not, and we determined it could be viable because it's time efficient, easy to implement, it's really flexible and scalable. Also, we have the opportunity to adapt to newer technology in the future, and our architecture can expand really easily with the modules. Okay, we did a timeline. It would take approximately 3 years to complete this project. You can see it outlined there.
And now, please, questions. Maybe what is important to mention is that you can use more than one sensor, and all the sensors are interconnectable. So. This one? Yeah. Yeah, so the first neural network tried to learn your home, try to learn your heat exchange pattern from your home, and try to learn your pattern, how you like to set up the heat inside your room. The second one tries to learn your region pattern and tries to exchange data, tries to collect data from databases, from weather, from climate databases, and so on, and also tries to fit in the real-time data that you can collect from a sensor put outside. And those two try to give a solution to the problem, also based from the experience that other systems mounted on similar buildings had. And then you control a standard controller. Yeah, sure. Yeah, we thought that if your system breaks down, we try to classify the problems using machine learning, using data classification, in order to bypass the standard procedure of calling and interacting with the human, which takes a lot of time. So we try to relay the problem, even either to the owner of the system. If, let's say, if you are the user in a bureau and the owner is another one, we relay it to the owner. Or if you are the owner, we relay it to the providers of equipment, let's say to Honeywell, and they will try to classify and optimize the support. Also, we have blackout detection. When your system goes off, you'll receive a notification. Also, Honeywell will receive a notification because in winter time, your whole system, your whole heating system could freeze up if it's left without power for a long period of time. Yeah, exactly. So why it is modular? We start with a temperature and humidity sensor, which has communication built in. It's very small, and it has on top an LCD display and some buttons. That's the basic stuff. It's just like a standard thermostat. You can put it on a wall, you can put it on a rack. It has also batteries included. But on top of this, you can add extra sensors like airflow sensors, light sensors, gas detection sensors, or you can add a layer that contains all the electronics needed in order to transform this smart sensor into an Alexa or a Google Home. So that's why it's interconnectable. We tried to use a USB standard connector in order to connect everything. USB Type-C because it's round, so you just stack them one on top of each other. But you can use, let's say, light sensor independently, only with the temperature and communication module. You won't need all the modules. You need only the communication one and others. From the user perspective, it will look like a small tower if you choose to stack a lot of sensors, or let's say not bigger than this mouse and not taller than this, if you choose only for a temperature sensor and a display. And you can mount it wherever you want. You can put a suction cup, you mount it on your wall, you put it onto your suction cup, and it stays there. So that would be the product design. We want it to be modular and easy to use. Yeah, we can. No, you need to have at least the communication module, because you have to send data to the central unit. That's all you need to have. And on top of that, you can build whatever you want. And the communication data is the standard, the minimum, the standard minimum. Yeah, yeah. Yeah, it is another independent module that can be added on top of other modules if you need it or if you want it, and wherever you want it. And you also can have multiple configurations of sensors in multiple rooms, and they can talk to each other and relay information to the central unit. Yeah. Well, let's say, all right. So we've mentioned that we have a target, a cost target, and a comfort target. You either satisfy the comfort target, you prioritize the comfort target, either the price target. It's up to you, it's your choice. But we try to maximize as much as possible the efficiency. Let's say if the sun was really hot, and you know from the weather that today will be cold, we will try to store as much as we can, as much energy as we can, because it's sure that tomorrow the gas prices will slightly went up because everyone will turn on their gas heaters in order to heat their homes. So we will use the technology in order to do that. But you can see the effectiveness of this solution when you use electric-powered devices, because in using electricity, there's a bigger variation of price, even from night and day. Thank you very much.
Well, time has come for the last and concluding presentation of today's case study. And please welcome Team Ukraine. Good luck.
Thank you. Hello, we are Natural Selection team, and welcome to our presentation. So, the technology nowadays is integral part of our life, and we decided to create a company that will be the first to provide the full service, best full service in the world. So, who will be our clients, customers? We focus on two groups people, and the first group is building companies who building houses and pre-install our system in their buildings. So the second group is ordinary people that from USA and Europe, middle class, and so we can sell our products for reasonable price, and in the region where this product is widely spread. Okay, so.
We would like to use Goodman heating and cooling system. It has benefits in price and also in efficient. All sensors and the main control block will be connected by wires because it is easier to install and much more reliable than using Wi-Fi. All the data will be sent to the cloud storage where it will be analyzed, and all the data will be fully protected and anonymous. About sensors, we would like to use 3 sensors. It's temperature, moment, and carbon dioxide sensors, along with dampers. They will be used for HVAC zones, so we can make it truly smart and control in each room separately. For example, the carbon dioxide sensors can be used to track the high level of carbon dioxide in each room separately. So imagine that there are a lot of people in the one room, and the sensor will understand it, and fresh air will be there immediately.
Okay, now some words about machine learning algorithm.
We had a research and found out that the best solution for us is to use a reinforcement learning algorithm to control our air condition system based on weather predications. In reinforcement learning algorithms gets to choose an action in response to each data point. Then our algorithm receive a signal with with a reward, tracking how good was decision. Based on this information, our algorithm modifies its strategy to achieve excellent highest reward. So we can say that this algorithm is naturally fits for IoT applications. But there are a lot of sensors in our house, and that's why we need to store a huge amount of data, and that's why we choose Amazon DynamoDB because it is a cheap and reliable web service, and it is easily to store and show data and even make a lot of operation with it. Thanks to Amazon DB, we don't need to worry about data, about security and anonymity of our data. But the key to succeed is to make our control system comfortable to do with. So just imagine you have a friend who just knows your habits, routines, and helps you to go through your life. That's why we offer a plug-and-play application, and you can change climate modes, you can change temperature, you can track in carbon dioxide in the air, and so it is a very good application for it, and that's why we need to sorry, but we didn't make a prototype of it, but it is in future.
Okay, so now asking the real questions. Why people will choose our company over the others? We know that we are entering a very hard and complicated market. Basically, we will need to compete with two types of companies. First, we are going to sell our technology to the companies, like the building companies, so they can implement it while building houses. And for that, we would like to use personal meetings and personal direct marketing. And for the second target group, well, it's obvious that people who want to buy something, they usually go to the internet. Our main client base will be in the USA and Europe. It will be like middle-class people who can afford to spend $2,000 or $3,000 on their house. And I think that's a huge target group. We'll create our own website. We will create our pages on Amazon, eBay, on Craigslist, and all these websites, so we can provide it there. So why us? We will be the only company on the market that will provide the whole system, basically, because there are lots of other companies and they have their own features, but they don't combine that together. It's like you just can't go there and say, okay, I just want no worries and all my house equipped properly. That's what we do. We have heating, cooling, humidity control. We have 24/7 hour support. We invented a little, different technique. We will ask our clients to pay $100 a year fee for maintenance, and for this $100, they will have a full 24/7 hour support, and also the engineer will check the system once 6 months for free. If nothing crashes and if nothing bad happens, we will give $100 back in the end of the year. So that way, client will kind of keep connected with us. The next thing is that we calculated the price, and it will be like around $2,000 and $3,000 for our thing. And you know what? The other main feature is that we will have the machine learning system that will allow us to make like a friend to the people, so that you come there, you have your air conditioning prediction in the future, and you have everything that you need that you can easily control. So basically, that will be the best thing in the market. Why don't you buy that? I will have mine in my house for sure. Okay, so thank you for attention. Any questions maybe? $3,000, I'm sorry. $3,000. What's motion sensors? Yes, and also the carbon dioxide sensors. Well, that's basically for the comfort. Imagine that you have your. I'm sorry. Well, yes, for sure. I mean, the whole engineering system, there are locations of the sensors where they should be. And I think like the motion sensor obviously needs to be located in a place where it can see all the room. The CO2 sensor also needs to be like somewhere near the roof. And the temperature sensor needs to be not in one place in the room, like to see the whole picture, because we know that the air on top is a little bit more warm and the one on bottom is like a little bit cooler, so we need to have the whole picture. And those sensors are not that expensive, so that's why we decided like to put 2 or 3 in each room for temperature, 1 carbon dioxide, and 1 movement. Did I answer your question right? Okay, good, thank you. Well, that was the one thing that we just didn't have time to put in our presentation, but I had an idea. When we have a promotion for the client, imagine you are investing $3,000, so like $2,000 or $3,000, that's a lot, but this gives you the economy, like you save $50 or $100 per month just by using our system, because we can basically put like different types of fuel. It can be gas, and can be oil, it can be electricity, wherever you want, based on your location. And by buying our product, you will save some money every month. So we can show like the diagram, and we just didn't have time to put it in the presentation, unfortunately, to show the diagram that will give the client like you will invest 3,000, and in 1 year you will basically have this money saved, something like this. Well, okay, thank you for your attention.
Thank you, Team Ukraine, for this passionate presentation. And thanks to our jury from Honeywell, from YITS, and from the Brno Technical University. And thanks to Honeywell as well for supporting not only the local group of Best Brno, but the whole network, and for helping this happen. We have come to the end of the day. It was intense, but everybody enjoyed it, students and jury as well, I hope. Thank you once more, and goodbye.